So, how's that look? Can you guys see that?
Here, let's just get the whole license. Oh, there you go. Just
Yeah.
that.
Only for this beginning part. I always start off all of my classes with this part of the slideshow, and it's to draw an analogy on what happens inside of our industry, or what happens in our industry. So I want you guys to take a really close look at this picture, and I want you to notice a few things. First of all, why it's up here is because there's a car upside down inside the water here. See the guy standing on it? I don't know how the heck it got in, but their job is to get it out. Okay, so I also want you to notice there's two people over here, one guy in a gray shirt and a guy in a red shirt. Okay, you guys all see that pretty good? Anybody see this picture before? No? Yeah. Okay, if you have, don't say anything, okay? Okay. There's my two guys. Any comments?
Get the car out, right?
Huh? Yeah? Yeah, where's the guy in the gray shirt? I don't know. The red. Oops. The red shirt's gone too now. Okay, so there is always a solution, right? So we made a mistake. We get a bigger truck. What do you call those? Outriggers? Yeah. So this is what they probably should have done in the first place. Yeah. Look good. But because of our first mistake, where's my guys?
Ran off.
Look right over here. This is the guy with the red shirt. I still don't know what happened to the guy in the gray shirt.
Oh!
Okay, there's my guy. He's still there. So, what does this whole thing have to do with irrigation? Really, or landscaping, nothing at all. But here's what happens. I started in this industry in 1985, or just about, and so I've seen a lot. I've seen a lot of things go on. I've seen a lot of good things, and I've seen a lot of bad things. I've made a lot of bad mistakes. I kind of learned. I started off digging ditches, and I did that for about 13 years. And for 13 years, I did a lot of wrong things. So I guess one of the reasons for this class is to kind of help jumpstart you guys and get you start doing the right things sooner than I did. There's a lot of messed up sprinkler systems out there because of me. So I work for Diamond Head Sprinkler, and I'm probably still selling stuff to people fixing those mistakes that I made. So that's kind of a bad thing. Now, these guys over here, they're kind of going through the same thing that I did. The problem with our industry is that a lot of the stuff that you guys see outside there, anybody can buy them. You can buy them at Home Depot, City Mill, or some version of what the sprinklers and stuff is. So What happens is a guy buys a pickup truck, he buys a rake and a shovel and a lawnmower and a blower, and now he's a landscaper, right? And so what happens for us is it devalues our industry or our trade. Yeah, so people don't have as much respect for us as they probably should. And the respect gets even less because there's a lot of guys out there that don't know what they're doing, right? So classes are designed, and when I teach, the reason why I do that is because I just want to help people out to get a little bit quicker ahead and start them on a path so you don't go down the same path as I did. So some of the stuff that we're going to talk about today, a lot of it is stuff that I did. So hopefully this all works for you. That sound good? What's up, Daryl? I saw your brochure over here, or your certificate. I was wondering if you really got to have that. I thought you wasn't going to come. How many of you guys actually work on irrigation? Wow.
That's how we got fixed.
That's why you got that. Okay. You're all Oahu guys, huh? So how many of you guys seen those irrigation systems on the freeways? See something in the bottom, see the water shooting, see the water hitting the road. How about parks? You guys see stuff in the parks at all? Not at all? Fields? Homeowners? Your house? Is somebody in a family? Well, so, what's that? Okay. Well, we can talk about some of that too. When we talk about sprinkler systems, the first thing that we have to consider is water. If you don't have water, nothing's going to happen. You can have all the best equipment in the world. So we're going to talk about this thing over here called the point of connection. All it really means is that's the part where a sprinkler guy or a plumber will tap into the water source to get water for the sprinkler. That's the point of connection. And at that spot, there should be this thing over here called a master shutoff valve. Okay. The reason for the master shutoff valve is if something should ever happen to the sprinkler, you want a way to shut it off so that you don't have to shut down the house or the building, or the shopping center because of a broken sprinkler system. Okay. Maybe if I open some of these windows.
You need more light or what?
I need more light. I'm gonna fall. Plus, I cannot see what I've got down here. Anybody know what this is? By the way, it's in your book. Gate valve. Okay. This is what we usually would find in the irrigation system to shut off the water. Inside of here, there's a brass gate that comes down when we turn the handle. And if you notice, it takes me like 100 times turning this thing before it goes off. Okay, I'm going to pass this around so that you guys can look at it. Here's a little picture. These are all inside of your book. Okay. So it takes multiple turns to get this off. What do you guys think of this? Anybody that's ever worked with one of these? You like them? Like them? Don't like them? Anybody? Takes a long time to shut it off. You know, when I was working, doing sprinklers, this is all we had. And then somebody introduced me to this other valve. Ball valve? Okay. Ball valve actually has a little stainless steel ball inside of it. And it only takes a quarter turn to turn it off. So here's a couple things that happen. With this one, it's metal to metal. And sometimes when they're brand new, it shuts the water off all the way. Majority of the time, it doesn't. Okay? 6 months down the line, I can almost guarantee you it's not going to stop the water. This is a typical kind of gate valve. Okay? There are others that have a rubber gate that shut off the water all the way. But the majority of them out there you're going to see is going to be like this. So number one, there's lots of times I went to houses or on properties or shopping centers, commercial buildings where I couldn't get the water shut off all the way, but it would stop it. Yeah, if something was broken. Then somebody introduced me to these, and I thought, wow, this is an awesome idea because number one, quarter turn, it's off. Okay. Number two, it always shut off the water all the way. Okay. Where do you guys see these? Hydraulics on your water heater. Air. Some of you guys use compressors. Yeah. So that's one sign that these things are designed to shut off, to hold pressure, to keep something off all the way. Quarter turn. Okay. Fire hydrant. When somebody hits the fire hydrant, you guys ever seen that? Water shooting like 80 feet in the air? Yeah. The car or the moped. And then the water's running down the road, and it seems like it's running forever. I mean, the water gets like this high, it's running down, starting to flood places over the sidewalk. And then the board of water supply guy comes out, and he puts on his raincoat, and he stands in the middle. Meanwhile, the whole traffic's starting to go all kind of different ways. Cops got to come out, because it's a hazard, right? Then the guy comes out, and he has this T-bar thing, and he sticks it in the road, and he starts to turn it, right? And meanwhile, he's totally getting pounded with water, right? And it takes him, seems like, half an hour to get the water off. He's just turning and turning. You know what he's turning down there? He's turning one of these. Yeah? So, the normal person be driving down the road going, these guys are so stupid. Right? I mean, water. I mean, they're telling us we got water shortage, and look at what they're doing. The water's just blasting down the road. We're using these. Why didn't we use a ball valve? Because they could have stopped it immediately, right? Yeah. Here's why. Really why. This thing takes a long time to shut off. If a car is running down the road and all of a sudden somebody puts something up and the thing hits it, what do you think is going to happen? That car is just going to get trashed, right? That's what happens with a ball valve. The water is running really fast. All of a sudden, it shuts off. What happens? The water hits the ball valve and bangs back. It's called water hammer. It could be 10 times more than the pressure on the street. You guys see how much our board of water supply lines break? Can you imagine if something like that was happening? So they would cause an even worse problem. They'd probably lift the road. Because then the whole big pipe's going to break, not something that was on the top, right? So, the reason why we use gate valves in irrigation is because, number one, I told you, the reason why that thing is there is if anything should ever happen to the irrigation system and we want to shut it down, we can shut it down and not have to shut off the house or the commercial center or whatever. And we want to do it slowly. Because usually what happens when water is running, we want to get it shut off right away. And it's usually panic, right? So if they had an opportunity to get one of those ball valves and crank it, one real fast one, you know what happens? We cause another problem. Okay? So although it may seem like the ball valve is a better idea, unless you know what you're doing, it's really a bad idea. Yeah, so yeah, you got to go real slow. Just like turning them on, you want to go real slow. So you guys probably more mechanical than most people, but a typical person out there trying to shut off water, they panic. Okay. Usually when things break, they always break at the wrong time or inopportune time, and we just want to shut it off real fast. Okay, so that's my thing. Give you a better picture here. There's your ball valve. That's my thing on the valves. Okay, questions? Comments? Anybody know what backflow prevention is? The terms are most of the terms in sprinklers are really, you listen to the term and that's what it is. Backflow prevention means that when water goes one way, we want to prevent it from going the opposite way. Okay? So there are devices out there that you guys may recognize when I turn this. This is a double check valve. I'm sure if you went out to the front over here somewhere, you'll see something like this. Usually what it is a pipe coming up and you got this contraption with valves and handles and all kinds of stuff, and it goes back down into the ground. Sometimes you see these things and they're dripping water. Yeah, some buildings, there's a couple of them in front. In the parks, they got these big ones with big handles on top, yeah? Big gate valves with chains across. What do you think the chains are for? Yeah, so nobody turn them. Yeah, because kids come and fool around and turn the water off. Okay, now, used to be, before, people weren't so concerned about this kind of stuff. And I never was too when I first started doing sprinklers, because I was wondering, why the heck do we need this? Because the idea behind these is that it only lets water through one way. This is a check valve, okay? It's very similar to what's inside of here. If you notice, on this picture, if you look real close, there's an arrow. And the arrow is telling us which way the water flows. Okay? So the water flows this way, but it cannot flow that way. If this thing is working right, that's what will happen. Okay, so this check valve has a direction too. Yeah, this is in, and that's out. So this is a double check valve. All it means is there's two of these inside of there. So there's one here and there's one there. Okay? So it's a double check valve. And its design is so that water goes through one way and cannot go back the other way. So I'll pass this around, you guys can look at it. Okay? This is a check valve. Now, why do we need these things in sprinklers? When do you guys ever see water going the opposite way? Thanks. Slopes. Okay. A break in the line. That's a pillar. Slopes and break in the line. Anything else?
Shut off the water.
When you shut off the water. Okay. Perfect. So this is what happens when this is my thinking. I come to the side of the house, I turn on the water, it goes this way. I turn them off, it stops. Turn them on, it goes that way. Turn them on. So put a hose and I put sprinklers on it. Turn them on, it goes that way. I turn them off and it stops. Now what they're telling me is I need to have one of these things between my water source, the faucet, and my hose going out with all the sprinklers. And I turn them on and off, and I never see it. So how the heck can that water, after I turn them off, go this way? Cannot, right? Because it's off. But when I turn the water hose on, the water's going this way. How can it go that way? So what do I need one of those things for? You know what I mean? When do you guys ever see you turn on your hose or your sink inside a house and the water go the opposite way? Right? Oh, it's come out, right? So I'm thinking, what do we need these things for? So, one day I was at Pearl Harbor, I was talking to an architect over there, and we were talking about these things. And all of a sudden I understood. So here I am, like 20-something years in the industry, and going, doesn't make sense, right? So, on a lot of the military bases, these guys that are enlisted, they get free houses. Yeah. So, but the idea behind this also is that they're provided with houses. These are houses. Okay. And here's a street going down. The idea with these guys is some of the rules is they got to take care of a certain area around. I think different bases are the same. Maybe it's like 50 feet away from the house. Yeah. And then all the rest of this, they hire a maintenance contractor to take care of it, right, for them. But, so, you know, they got to take care of it. So sometimes people think, you know, I just not going to water them because then I don't have to mow, right? So, but they cannot do that. They have to keep it green. So what do these guys do? They run down to Home Depot, they run down to the help center on the base, and they go buy all kinds of different sprinkler heads, and they do what I did. They go to the hose, right? They put one little battery timer. Thing comes on every day at 5 in the morning or something. They run hose, and all the sprinklers pop up. Some guys, they get real good and creative. They dig a trench. They drop the sprinklers in the ground. They might drop something like one of these, yeah? Thing sitting in the ground. At 5 o'clock every morning, the thing come up, automatically shoots water, then it shuts off, goes back under the grass. Okay, so these guys are all doing this thing, all of these guys, because they don't want to hire a contractor because it's not their house, right? They don't want to hire a contractor, so they put their own sprinklers. So right on the side of the house over here, they put this little battery-operated thing, and they run one pipe, and they got sprinkler heads like this. This guy did the same thing, right? So one day, this house right here get on fire. One morning, 5 o'clock in the morning, the fire truck comes up here. Everybody's sprinklers are going on. 5 o'clock in the morning, right? The guy hooks up, the fire truck comes in, he hooks up to this fire hydrant right here and starts hosing this house. What do you think happens to these guys' sprinklers?
A lot of pressure.
Yeah? So everybody's sprinklers is going like this, shooting water, and then this sucker over here, because of him, took all the water. What happens? Things go back down. Now, we got backwards flow. Hardly ever see that, yeah? Hardly ever. But it happened this day. So this is what happened. He's thinking, so? The water stopped, right? But what's on the ground over here? Fertilizer, dog poop, flea spray, because we don't like our dog get fleas. And all that water that's sitting on the ground that's puddling when this thing goes down, starts to go this way. And it comes up the hose, goes inside my house, goes through the house, goes into the pipe over here. So they put out the fire, right? And everything is good. And they turn the water, they put out the fire, they shut off the fire hydrant. All the lines pressurized again. Nobody's thinking anything of it, right? A week later, choked people coming into, what do you call it, tripler? Sore stomach, diarrhea. And they're wondering, what the heck is going on? Then they start to notice that all the people on this street are the ones that are coming in. Okay? So they went out and they did a little investigation. What's wrong with the water out here? Maybe it's the water. They come out and they start noticing all these little sprinkler systems on the side of the house people put. Okay, no backflow prevention. Because I told them water only flow one way. Never goes back this way. Never does. So that's when the guy told me about that, suddenly everything opened up for me. I was like, whoa. This is super, super important. So, you guys ever put in a sprinkler system if you decide, you know what, I'm going to get into this and I'm going to start doing this? These things are so, so important for you, not just the guy that you're doing it in, because if ever something should ever go wrong, like the fire that you never plan on, guess who they're going to come back to? So licensed contractors are required to put these things in. It's part of the thing that they go through when they take their test. What is backflow prevention? It's preventing the water from going, when it goes through the sprinkler system, from going back the other way. That make sense? Okay, check this one out. This is called a reduced pressure backflow preventer. I like this one better. Remember I told you guys sometimes you might see things dripping? Usually there's a pipe goes in here. So the water flows like this, and it goes to your sprinkler system. You ever seen in the park or somewhere else, maybe by a shopping center, you see one of these things? Lots of times they're big, and water's dripping over here constantly. Okay? What that means is that this thing is working. Okay? It's doing its job. Because on the other one, with the two check valves, if something went wrong and the things got stuck in an open position, then water can go both ways, nobody even know. So what they started doing is they started to require us to use stuff like this. This is called a reduced pressure backflow preventer. What happens is, if something goes wrong with one of these check valves, like if there's a rock inside and it's not operating properly, the water can drip this way instead of going back through that way. With the other one, the old style one, the double check valve, something go wrong, nobody would ever know. Yeah? So before, they used to require that they only use these on places where they manufacture stuff because they're using chemicals. But then they found out, because us guys use fertilizers and pesticides, that they better start using it in landscapes because it's just as bad, maybe sometimes worse. Okay, so this is called a reduced pressure backflow preventer. It doesn't reduce it's not designed to reduce the pressure. The reason why they call it a reduced pressure backflow preventer is because if on this side, if the pressure is ever less than on this side, like in fire, and the water's going this way, instead of the water go that way, it's going to dump this way. Okay, so same thing, got two check valves inside, but then they got this extra thing over here that dumps water.
So whenever it's dripping is a problem.
Yes. Yeah. Normally, there's two, right? Normally it's this one.
And not dripping, then it's working.
Yeah. So it's kind of a funny one, yeah? If it's not dripping, that's good because nothing's wrong. But if it is dripping, that means something is wrong. Yeah, but it's doing its job. So, okay. Sometimes it's a drip. Sometimes it's full on.
Yeah.
Yeah. Yeah. And then sometimes when the sprinklers come on, the thing will flow, and then all of a sudden the thing will stop. Sometimes after the sprinkler system goes on, the thing will run for a long time and then shut off. It's all problems associated with these valves over here. Okay. Supposed to be that these things are supposed to be checked once a year by a licensed plumber who's certified to do these tests. And you see all these things over here? I used to think you turn them on, water come out, it's a good place to wash your hand and stuff. What it is really for is for these guys to shut off different valves, put tubes inside, see if the thing hold the pressure. If it does, that means those two things are working. Those check valves are working. So it's for testing purposes. It releases air, yeah. But what happens is you put a tube over here and you put a tube over here, you shut off the water, still get water inside. If the pressure starts to leak, go down, that means water is getting out somewhere. Something wrong with that check valve not holding. Okay. Yeah. It's a plumber, typically. I don't know if Board of Water Supply has any testers, but it's a test and a long class. It's kind of a difficult thing to get through, and they test you on all the different ones that they got. You learn all the theories. They call it cross connections of what happens, what could happen, and then you're supposed to go check. The only place I've seen these things checked on a regular basis is schools. Why? Choke liability, right? I mean, the kids get sick, or you. So, any more questions? No questions?
What's the location for that gas?
Huh?
As far as the whole system,
Oh,
where's the backflow preventer go?
Jay's question was, for a sprinkler system, where is the location of the backflow preventer? So I'm going to put something up here. Let's do this. Okay. So here's our water meter. This is our gate valve. The next thing in line is the double check valve, or the reduced pressure backflow preventer. Okay? I'm going to leave that there, so I'm going this way. Any more questions? Okay, I'm not saying this, but some of this might be on the test. I mean the quiz. Anybody see any of these before? Where you saw that? You never? Anybody seen this before? I do see them. Like I see some of these on Hickam Air Force Base. The other place that I see them most often is on swimming pool fields, on the side of the house. So what they do is, they got one of these. This is an open position, by the way. If it's like this, it's off. Yeah. So this is open. So what I'll see is I'll see one open, and then one off, and then when the guy cleaning the pool comes and he does his trip. And he comes over here and he turns this on and fill up the pool. Now, this is called a pressure vacuum breaker. It is actually supposed to be here on the main line part of the irrigation system, the pressurized line. This thing's supposed to always be under pressure. So these guys have actually got wrong application here. But when you're dealing with swimming pools, it's the same thing. You got acid, chlorine, all kinds of junk inside the water. They need to have something that prevents the water from going the opposite way. And they'll usually put it on their pool fill. Okay? These things mess up a lot on pools because they're not supposed to be turned on and off, on and off. Okay? These valves are only supposed to be shut off for testing purposes, or if you need to keep the water off, not on and off every day or every week or whatever the case is. What's that? Yeah, that's what they do. They use it to top off the water. But this is a mainline component. What they're doing is they're using it like a faucet. Yeah, turn it on and turn it off. Okay, so it's very similar to these, except there's only one check valve in here, and if something goes wrong with this, the water comes out of this bell over here. Remember the other one drops? Yeah, so this one comes up the top. You guys probably won't see too much of these on the highways, but you might see these. You guys ever seen this before? Usually the way it is they will sit above ground. So here's the ground level like this, and the pipe go in and come out. And usually what happens, and maybe some of the manual system, there might be a valve on the ground over here, you turn it on and the sprinklers come on. Okay. Usually this is super old style, but you might see on some of the freeways, because some of those systems are pretty old. This is called an atmospheric vacuum breaker. And it's the same thing. You turn water on, you turn it off, the things start going the opposite way. So if it wasn't straight pipe underground, the water will go both ways. Okay, so this thing breaks the siphonage of the water. So the water goes this way. When it comes back this way, instead of the thing going through, what it'll do is it'll come out of this cap over here. Sometimes, if you guys mess around with this, you see, I've seen it a lot. The sprinklers come on or you turn it on. As soon as it comes on, a whole bunch of geckos jump out, cockroaches, all kind of weird stuff. So what happens is right through here, the way I do it like this is this cap right here. There's air. And inside over here, there's a little flow. And in a closed position, if the water should come back, it'll go like this and it'll come out here. It won't go this way. Okay. But when the system comes on, that thing, when the water comes up like this, it goes up and it seals like this. So the water is able to go this way. Yeah? Yes, up and down. So this is what happens. The geckos, they all cruise when this thing is like this. They come inside here and they sneak inside and they cruise and they crash out, lay eggs, all kinds of stuff. And then, when the water comes on, thing goes up here, that's why they jump out. Sometimes only parts of them come out. And they get stuck inside the sprinkler. Seen that too. So, that's what that's all about. Is it 6 inches, Darryl, above the highest head?
It's supposed to be above the highest head. So
6 inches or 12? I think it's 6 inches above the highest sprinkler head. Okay, so there's a problem with these because we all know that in Hawaii all our yards flat, yeah? The freeways are all flat. So if there's a slope like this and you got one of these down here, right here, and you got sprinkler heads up here on the slope, guess what? This thing got to be this high. So you have pipe coming out for it to work properly. either that or you got to change location and put it up here. Yeah, so they don't usually work. And not that many of these because these guys go after every single sprinkler valve. So what happens is every time you see water going like that, got to have one of those. So can you imagine in a big park how many of those we're going to have? And then they become a tripping hazard or something for us to vandalize. They got plenty of these. Where you see plenty of these is in Old Mililani Town. You know those the landscape areas in the middle and on the sides as you're driving into Mililani? They have the old style like this. And this is worth a lot of money too, especially when they're like this big. Okay? So on our sprinkler system, we have the water meter, we have the gate valve, we have our backflow preventer, whatever kind we got. And then the next thing, not sure if we're always going to have these. It's called a quick coupler. This is what it looks like when it's underground. So, you guys ever seen one of these before? Yeah. You see them where? Schools and parks. You guys ever see these?
Is there at the graveyard?
Got at the graveyard too? Is that where you work? Where was that? Any place else? Huh? Oh yeah. Okay. So some places, what they'll do is they'll have a sprinkler on top of here. Yeah. So what's underground is one of these. The cap opens. You stick this inside, and then you turn it, and then water comes out. So if I had a sprinkler head on top here, it would straight. Lots of times in ball fields, huh? It's called a quick coupler. Quick coupler valve. This is the key. You can do that, or you can put one of these on top. So if I need water to hose down the someplace or water my trees, normally once a system is in and it's working automatically, we very rarely use these. But I'll tell you who does use these on a regular basis. So I'm down at Alamana Bowls and I'm surfing. I come in. My van says Diamond Hit Sprinkler on the side, right? Early in the morning, guy comes up to me and goes, "Hey, Rob, you get one of these. You guys sell these." And I'm looking at these guys going, "Well, how do these guys know about this?" I go, "What are you going to use it for?" We go, "Oh, we got some plants over there. We want to keep it alive. No more sprinklers." So these guys every day are watering the grass that they planted by their surf spot. They cleaned the spot. And then one day I'm driving down Kapiolani Park. I'm going down Kalakaua, past all the hotels. I look on the left, and I see right in the middle of the field, I see one full-on shower head, water balloons, kids running all over the place. Okay. So on the main line, that's where these things live. Okay, those things. And this is the key to get into it. Huh? Yeah, you hook up one, put this in the ground, turn it on, put on pole with a valve and shower head on the top. You need to walk all the way to the bathroom, right? You took one. You can put a hose bib on the bottom, a shower head on the top, so you're all set when you're cooking. So let me say something about this. Do you guys think you guys should drink the water that comes out of this sprinkler? Why not? Okay. Here's the thing, and this is my thing about PVC pipe. Have you guys ever noticed that when the sprinklers come on and they hit the cars, the water spots are really bad, like super white spots, and they're really hard to get off? But if The same thing, if you went to your house, is the water coming from the same place, right? All coming from the boiler water supply. But if you went to your house and you got a hose and you hose on your car, you can get water spots, right? But not as bad as the stuff that comes out of the sprinkler system. Okay? Same water. Okay? So, and I'm talking about drinking kind water, what we got coming to our house. So we used to get complaints all the time from people that, you know, the sprinklers are hitting the car, major water spots. You got to take them to the detailer. We cannot get them off. So, PVC pipe, polyvinyl chloride. We used to use PVC everywhere. In the hospital, plastic cups, plastic bags, put the cups inside, blah, blah, blah. Did you know that in the hospital they don't use that kind of stuff anymore? What we are finding out is that there's a residue in that polyvinyl chloride pipe that leaves, that moves, that goes inside the water. And is it bad for you over time? It could be, yeah. So that's why they don't use that stuff in the hospitals anymore. So what I used to do when I was working for many, many years is I would turn on the sprinklers, fill my cup, fill my water jug, wash my hands, everything, right? Because it's clean water, because it's coming from the boiler water supply. Same thing as I went to the house, right? But no, there's a difference. Just like those white water spots on the car, something's going on over there. There's a huge move right now to get rid of PVC pipe for drinking water supplies. I think it's a good idea. The other reason is what you mentioned, is we use, a lot of places, like in Evo, we use reclaimed water. So, like on the road going down into Evo Beach, we never ever want to go and tap into that water and think you being smart, stealing water, you know, free water, but no, because all of that is reclaimed water. Yeah? So you ever see purple? Do you ever see one of these things with a purple cap? The purple color means non-potable. It's a universal sign, do not drink. If you see the yellow, then drink it. No, same thing. Even if it's clean water, okay, I would not drink it. So, is this really a good idea out in the park? So I'm trying to get you guys not to buy these. I mean, you can buy them from us, but it's not really a good idea. I was at the, when they were building the Hyatt Regency in Waikolo. It's now called the Hilton. Right next to us was the Manalani. This back in the 80s. And we're in the lava field putting in sprinklers. Right next door I had one golf course. I knew nothing about this stuff, right? Theirs wasn't reclaimed water, but it was like groundwater. So what I did, I was thirsty. My jug was empty. It wasn't lunchtime yet. What did I do? I filled it up. And I did that for weeks. And then all of a sudden somebody told me, bro, you're not supposed to drink that. You know where that water comes from? I had no clue. So irrigation systems, PVC pipes, don't touch it. What's this? Coupler key. What are they used for? It's like getting a hose bib on a sprinkler system. Most of the time what the landscapers will do is they'll use these things to water in their trees, because that's one of the first things that will go in a landscape. The sprinkler system not working yet. Okay, and they need water to plant those trees. So here it is. Questions? Oh, there's a good picture. Kind of like a check valve. When the key goes in, it pushes down, water comes through. When you twist it up, it goes like this and it seals. You guys doing okay? When do you guys usually break? Right now? Let's go a little bit more, okay? Because we have kind of a lot of stuff to do. So what I want to talk about now are these things called controllers. The way a sprinkler system works is we have a main line piping system, all these things that we talked about. The next thing in line here is called a control valve. And what its job is to do is after this, there'll be another pipe where all the sprinkler heads are. Okay? So, there's water pressure all the way up to here, just like our house. Water pressure all the way up to the faucet. When you turn the faucet on, water comes out. So this is basically the same idea. This is like a faucet. It's called a control valve. And when you turn it on, it fills up this pipe and all the sprinkler heads start to run. Okay? On this side, it's called the main line. On this side, it's called the lateral. Okay? So, this control valve. The other thing about irrigation systems, sometimes you gotta turn these things on manually, which means anytime you want to water, you gotta go turn it on. It's called the manual system. And then there's automatic systems where you have controllers. This controller has a wire that goes to that valve. Basically what it is you set up a time when you want it to water, and that controller will turn on that valve automatically every day, every other day, or whatever schedule at a certain time, so on and so forth. So that's basically how this whole thing works. Does that make sense? Okay, so I want to talk about this thing right here now, the controller. I'm sure that there are still some of these controllers out here. They may look a little bit different than this, but this is called an electromechanical controller. Okay? We don't sell them anymore. They don't manufacture them anymore, but they're still out there. Some of them may be 50 years old and still running. That's one thing about before. The old stuff, they never broke down. Then they started remaking this, trying to make it cheaper. Okay, and then they started to break down because we started buying the little motors that run these things from somewhere else as cheap as we can get them. They didn't last. They're good controllers because they're very simple, and when you look at them, they'll tell you, this wheel here tells you how long the sprinklers are going to work. There's a wheel that has the date, and the time. So there's like 24 pins over here for every hour. Whenever something's pushed, you can look at it real quick. You go, oh, it's going to water at 5 in the morning, and it's going to water every day or only on Wednesdays or whatever. You open the box, and immediately you can tell what the thing does. Really simple, on and off switch. Okay? So these are electromechanical controllers. The reason why they don't make them anymore is because they're like those old clocks. How many of you guys wear wristwatch that have those little gears inside? Those are usually the real expensive ones, like Rolex. You know, they got all the gears. They're really cool, but they're very simple. Yeah. But most of us wear kind of digital watch where there's only numbers, but it has an alarm clock, timer, stopwatch, you know, date, year, everything, right? These things don't do that. But believe it or not, those little digital watches are more cheaper than the one with the gears inside. That's what happened to these. Because they got gears and motors, they became more expensive because somebody had to actually get there and put it together. But the digital stuff, the digital clocks, nobody had to touch them, all automated, right? No man touches it, except for putting it in a box maybe. Okay, so these are obsolete, but I wanted to show you one anyway. That's why the picture's kind of funky, because it's hard to get a nice picture of something that they don't make anymore. Another thing about these is they work on fuses, kind of similar to your car. Where something goes wrong, the fuse blows. And we're going to talk about some of that a little later. So, maybe you guys have seen this controller before, because I know they're in some of the parks, and maybe on some of the highways. This is a Rainbird controller. This is a fully digital solid-state controller. The only thing that's not is the dial that you turn. Okay, but every time you turn the dial, something digital happens there. So, no fuses. Wait, maybe that one does. This is older. Here's another solid-state one. And then we have battery-operated controllers. we sell a lot of battery operated controllers. And part of the reason why is because there's a lot of those controllers like this with wires. And one of the big problems with this is the wire. Yeah? And then a lot of people that work on sprinklers don't know how to fix the problems with the wire. Yeah? Or don't know how to fix electrical problems. And you guys are going to do some of that today. So what happens is when something happens to the wire, what do? Cannot work anymore? They put a battery controller in there. That's why these things exist. They were originally made for temporary, but now they've become more and more permanent. We sell these things every single day. We sell these things. It's unbelievable. So I'm going to try and teach you guys, if you guys are, ever get into this, how to fix these electrical problems, so you stop coming to my store and buying these battery things. Sounds kind of crazy, right? Anybody work on cars? Because I know some of these things happen in cars. For these things to work automatically, they have to have some kind of electrical thing, whether it's battery operated or if it's run by regular power, electricity. This is a cutaway model of one of the valves that you guys may see out there. What it has is this thing here. When I connect wires up to here and it goes through the controller, that's how it comes on electrically. This thing right here is called a solenoid. This is another type of solenoid. Okay, if you notice, this one has red wires, and this one over here has red and black wires. The reason why I'm going through this now is because that next photograph over there, because I'm kind of controlled by this PowerPoint. You gotta follow it. Red and black wires. This is for battery. It matters with batteries because in a battery there's a plus and a minus side, right? Okay. The way these things work, this is a solenoid. This is called a latching solenoid, and they're only used for battery operated system. What happens is there's a little plunger in here, and when I put that plus charge to this solenoid, what happens is it pulls up the plunger and it latches. It gets stuck. So all it takes is one pulse, and then a negative pulse, and it kicks it down. So that's what this is. This solenoid is a little bit different. This is called AC solenoid. AC is the kind of power we get out of that wall there. Okay? In order to keep this plunger up and this solenoid active, I have to have constant power here. So if there was electricity going to this and the wire got cut, it would turn off. This one is different. Once it comes on, it's on. I need another pulse to shut it off. This one has constant power. It needs constant power. Okay?
Stay off then.
To stay on.
Stay on.
Okay. How the solenoid works is there's a coil of wire like this. Okay? Inside, there's a plunger. When electricity comes to this coil of wire, it creates a magnetic field, and what it does is it pulls the plunger up. Okay? So I need that power there, creating that magnetic charge, hold this plunger in an up position. As soon as I take away the power, the plunger goes down because there's nothing there. Okay, so that I think is the simplest explanation. So I don't know if you guys ever seen this, but I also heard that in science class we did this. I was absent that day. Plus and minus. It's a battery. If I had a wire and a nail, and I had the wire coming out like this, and I touched, I would do the same thing, create a magnetic field, and I would move that. Okay. So that's a solenoid. This thing lives on top of here. Right here. So what the clock does is it sends up 24 volts to this solenoid and it turns the valve on. Question so far? Now, if something happened to that wire, I can do this. I'll put one of these battery ones on top here, okay? And I put a battery timer. Basically what it does is at whatever time I want it to come on, I send a positive charge. What it does is it clicks that solenoid and it latches. Oh, here it is. It latches. What's inside of here is a magnet. So when the plunger goes up, it gets stuck. It latches. And then I send a negative charge and it kicks it off. Okay? So those are battery operated. Then we have solar. You guys ever seen these before? Not that good of a picture. They look like parking meters. This one out here, yeah. They look like parking meters. It's one of the most popular ones. They were all over the state at one time. They are basically battery operated controllers, but they charge by solar electricity, so you never have to change the batteries. They're very expensive, but they do work. And that same company came out with this one. I personally don't like them, but I'm starting to see them out there. And what it is just a little solar panel. There it is right there. So that whole controller sits underneath the lid of the valve boxes. And then this thing right here, the control valve is underneath. The reason why I don't like them is because they're super prone to vandalism, especially where there's a lot of kids. And they're very expensive. And if it was me putting it in, I wouldn't do it because I'm not going to have to replace it because of either vandalism or somebody stole it. Yeah. You take off the lid, everything's gone. This is a picture of one of those solar solenoids. They got their own thing going because it's super, super low energy. So the solenoid is actually right here. Then they got this wire and they got this little capacitor thing that carries a charge that gets charged up by the sun. So all kinds of funky things. Here's another picture of one of those types of solenoids. Notice in this picture the red and white wire. Whenever you see a solenoid that has two different color wires, that means it's DC, yeah, where polarity matters. Any questions? Let's take a short break. We're going to go into something completely different. The question is if we have a power outage, well, let's just start. I'll go over the whole thing. What's going to happen and what is the battery for? The first clock that I showed you, the electromechanical clock, they never had batteries. So if the power went out, it would be like our old clocks. It would just be slow. And for as long as the power outage was, that's how slow it's going to be. Then they came out with digital clocks. The very, very early ones, when they first came out with a little place for a 9-volt battery. And what that 9-volt battery was designed to do, number one, was to make sure that all the program that you punched in, like what time you wanted to water and this and forth, so on and so forth, stayed there. Also, it kept the clock running in the background so that the clock would not go away. Remember those old alarm clocks? Maybe we still have them because they still run. If there was a power outage, you would wake up late. You never know, right? The thing would come back on, but 2 hours later. Okay, so if you had a battery in there, then it would keep the time running, and then you would wake up on time, right? If the power came back on. So that's kind of like how the controllers worked before. But now, and it's been for quite a while, they put this thing in the clocks called non-volatile memory. And what that means is whenever you punch into, it's like a computer, whatever you punch in, like I want it to water every Wednesday and I want it to run for this amount of time, blah, blah, blah. That program stayed. So the only thing the battery was for was to keep the time. Okay? So if your battery was weak, then program would still be there, but it would run at some funky time. So usually what happens is if there was a power outage, the clock, when it came on, the clock would restart itself. It'd start at 12. No matter what time of the day, it would start at 12. So everything would be wrong, right? it would water every day, but just at some weird time, because it thinks it's 12 o'clock, when it could actually be 6 o'clock, right? So, so non-volatile memory means that all the program is there except for the time. It's the only thing it's not going to save. So that's how most of the clocks run now. The newer clocks that are coming out, they don't have a battery place. Well, I should back up. They do have a battery slot, but the way they work is they're usually what they do is they put in a lithium battery. They're usually like a 10-year battery. Electronics don't take much to run. They don't draw much power. So those lithium batteries, they last forever. So the new clocks, they have non-volatile memory. They have a lithium battery to keep the clock running. You could have multiple power outages, and the clock will still be at the right time. Yeah, so no worries. The battery slots in the new clocks, the only reason why they're there is to keep the LCD display on, so that if there is a power outage, the clock will say no AC or no power, just to let you know that the plug, the source is not there. The new clocks, I mean, I've seen that it could be up to 30 days with no power, and then the power come back on, suckers, right on time. Okay, so, does that help? Okay, any more questions on that? What we're going to talk about briefly is about this thing right here. It's called the remote control valve, or a control valve. And it is on the same line from here to here, the pressurized line, which we call the main line. It's controlled by this thing here. We talked a little bit about controller. One of the new things that you begin to see, well, you probably, if you're out there, is you see is this is an add-on. It's called a pressure regulator. Basically, all it is a device that reduces, most of the time we're using it to reduce the pressure for sprinklers, because sprinklers don't need a whole heck of a lot of pressure, contrary to popular belief. The range for most of our typical use is somewhere between 30 and 60 pounds. You don't need 100 pounds on the sprinkler head. They won't work right. And if in case you do, this thing will help you to get that in the right range. They're add-ons. They usually will go between the valve and this here. Some of them you'll see they come off the side. Those are really expensive ones, but we're most of the time moving in this direction with just the add-on ones. Okay. If you turn the dial, you'll see the yellow line moving. There's bar and there's PSI. Anybody know what bar is? I don't really know what it is either. All I know is I used to have a regulator. It was made in France, and I was diving, and it was cheap, so I bought it. It was used just for to see how much air I got, and it was in bar. And it never made sense to me. All I did was watch the needle. If the thing went too far, now I better get out. So on this one, what you want to look for is PSI. That's pounds per square inch. That's how much pressure. In case you can turn and move them around. Questions? Oh, virus protection. Okay. This picture right here is a Rainbird control valve. Oh, here it is. There's a couple things that I want you to see. Number one, this is the solenoid. Remember we talked about that as this thing here. The electricity goes and it lifts a plunger. There's another handle up here. It's called a flow control. You can what this is used for is regulating how much water goes through the valve. It could be just a little bit or it could be a whole bunch. Okay? And over here there's this thing called a bleed nut. A manual bleed nut. And what happens is when you open this, water comes out and then the sprinklers come on. Water flows through the valve. So there's two ways of actually operating this valve here. One of them is electrically through the solenoid, and the other way is manually through this bleed here. Nowadays, majority of the valves that are out there has the option of turning on the sprinklers manually from this solenoid without electricity. And basically all it is a quarter turn, and then the sprinklers come on. Okay, this is probably, if it's available, the better way to run than this. One of the problems that's associated with these things, which by the way we stock a lot of them, is that people turn them and the water comes out, the thing flies off and they lose it. Now they're stuck. The water's running all the time. So the other thing is it's threaded, and lots of times with things that are threaded, they get cross-threaded. And if that happens, then you get to replace the whole thing. Or actually, we sell the top here too. We have to. Okay. That's a picture of that regulator that's going around the room that I was messing with. So you notice the valve looks a little different. Here's the solenoid. Here's the pressure regulator. Oh, check this out. There's something missing. I never noticed that. See that, Tara?
The pressure regulator, how does it regulate the flow coming out of pressure coming out of the valve?
I don't know. Do you know? Yeah.
What about
I really don't know. That's a good question.
can you get the flow?
Okay. That is a really good question. I can answer that one. I can't answer yours, unfortunately. But it works. Okay. It has something to do with how much water it lets through over here. It only controls here. So, but beyond that, I'm not real positive. Okay. Your question was this here, right? Can't we just use that? Okay.
Bill, writing everything down and Bill. When you grab the other one, you grab that one.
That's kind of a challenging question. But let me just see if I can do this. Okay. Here's a pipe. Okay. We measure pressure. It's called the word is called static. Okay, there's two types of water pressure. One is static. Okay. And the other one, that's when water comes in here and it's stopped here. Okay. And then there's another one called dynamic. And dynamic water pressure is when water is moving. Okay? Now, if I took that valve and placed it right here and left it completely open, fully open, my static pressure here, when the water's not moving, let's say it's 50 pounds. If I shut this thing down so that, let's say I shut it down, so now I only got 50% of the thing open, my pressure here is still going to be 50 pounds. You see why? I mean, even though it's halfway shut, it's still, there's no reason for it to get any stronger. Okay?
The volume of the water coming out.
The volume will be less. Okay? So, with this thing here, when you turn this thing down, you know what you're actually doing? Is you're reducing the volume. What we measure pressure is, typically is static pressure. Okay? Now, let's look at this real quick. Hope I can do this explanation. Is that clear so far?
What is that for?
Huh?
So,
Okay, for this, okay, what this is for and what it's called is a flow control. So what it's doing is it's controlling the amount of water that goes through the valve. Okay? You could actually control it so much that you could shut it off. Yeah? Or you can control it to a point where it's only 50% of the water can go through. Okay? There's a little bit more to this. I'm trying to make it usable. Yeah? That's basically what that handle is for. If I shut it all the way, then I cut it all the way off, then I got nothing. Or I can do it halfway. So, the sprinkler is running and it's shooting really high and really misty, like there's too much volume, I can actually take that handle and turn it down and reduce the amount so that it works properly. So it's going like this and not just some big mist of, yeah. If the sprinkler head is up on the hill, yeah. Yeah. Yeah, so you're right. Pushing water uphill is going to take more. Yeah, so you need to probably leave it more open than you would if it's going downhill or if it's flat.
So, I don't get like, so we need that, you can put any kind of valve, right?
Any kind of valve,
Any
like,
kind of shut-off valve that
okay,
can be control the water, right?
you can, but here's the problem with that. Okay, see this gate valve? So this is one way that people do it. They get too much water, what do? They turn this thing halfway. Okay, these valves are designed to be installed all the way open or all the way closed. It is a shut-off valve, nothing more. Can you control water with it? Yes. But what you're in danger of is you're going to break the valve. So I've been in places where people did that. Yeah, or maybe they just mistakenly turned it on, thought they turned it on all the way, and it's like this. So I went to shut off the water because I had to do something. You know what happened next? When I go for turn it back on, it doesn't come back on. Yeah, or I cannot shut it off. Or the handle just spins and spins because it was left in this position. Okay?
So that's the reason for using this kind of valve.
Right. On these things, they're designed to be halfway off, almost all the way off, all the way on, or whatever the case is. Okay? But not these.
So for the other controller, I'm seeing the only reason you're putting them off because we got multiple sprinklers. When you hit the, when you're controlling them, the first sprinkler within the line, you see you got 6. Is it going to be different from the last one? That's why you got the other.
Okay. Have you seen that?
No,
Okay. Okay. This is a good question. Do this. If a system is designed improperly and it comes on and this thing has more water than this one, the reason why is because they put the pipe over here is too small. They should have put a bigger pipe. So that should never happen with a properly designed system. Okay? If it's designed properly, the pipe will be sized big enough so that we can get water to all of the sprinkler heads. Okay?
It's the same size from beginning to end.
It could be that. Yeah. It could be that. The major reason why we make pipes smaller and smaller is cost. Because this sprinkler head only needs X amount of water. Why put a pipe this big? Will it work if I put a pipe this big? Yeah, it will, but waste money. Why run a pipe that big? So, if the system is designed properly, you will not see more water here than over here. You ever seen people run lights, like outdoor lights, and then the first one is bright, and as you go down, get less and less and less? That's improper design. Sprinklers are kind of the same thing. If it's designed wrong, you're going to have less water here. But the reason for the flow control is really because in our yards, nothing is ever equal. Okay, the backyard not going to be the same size as the front yard. The side yard is even smaller. So they might have different size sprinkler systems. So this one is small, this one is big. So I have enough water to run this one. That means I have enough water to run this one. So what should I do? I'm going to adjust this valve for the amount of sprinklers because this one get more. This one might be all the way on. This one might be 3/4 of the way on. Okay, so that's the reason for the flow control. If you have a system that sprinklers coming out here strong and this is small and the way you control them is here, then the system is designed wrong. probably because of the pipe.
Size.
Wrong size, yeah.
This was the same size all the way.
It could be. If you guys want to come back in the summer, I teach a whole class about how to make those pipe sizes right in the design course. It's kind of interesting. It's kind of fun. So, does that make sense? If I see Daryl's head go like this, it means I'm saying something wrong. So far, you never do that. Yeah.
So we need to equalize the pressure if it isn't getting the proper pressure all the way to the end.
You mean like from here to here?
Other than the valve.
Wait. So your problem, let's create a problem. So if there's pressure strong here and pressure weak here, is there a way to equalize it with something other than the valve? Not really. The problem it would be the pipe. The pipe is wrong.
Change the whole pipe.
Yeah. See, so if let's say this sprinkler head needs 4 gallons per minute in order for it to work, and this one here is the same. GPM. Okay, they both need the same amount of water, and this one is actually only getting 2. That means somewhere over here I made a mistake with the pipe size. It's not big enough to give this 4. Get 4 all the way here. So there's no.
That means you're a quick fix instead of tearing off the
No.
whole pipe.
No. Unfortunately not.
Unless you put a water.
Actually, there is.
Another water source on the other end.
There is a way to fix it. Make all these heads smaller, but then they won't shoot far enough. Okay, the other option is to put a booster pump, but then you're going to have all kinds of pressure regulating heads. Then it gets really super complicated. So if it's designed properly, you don't have to have all of that stuff. So really, the answer is, yeah, tight. Better repipe.
In that case, should you make sure that the flow control is all the way open so that you are getting maximum flow through there?
Yeah.
But if it's a situation like that, it may, the flow control may be already set past by somebody for some reason. So one quick way might be just to go to the control valve, make sure the flow control is all the way on. Would that work?
So Jay's question is, in that case where we don't have enough water, should the valve be all the way on?
I'll make sure that it is all the way on.
Yeah. Yeah, but if you're having a problem like that, you're still gonna have the problem.
So you know if you have the right pressure before you bury it, you should test it out.
Yeah. Yeah, that would be, that's how I used to, yeah. That's how I used to install sprinklers. But there are some rules that are pretty simple. If you decided you wanted to put in a sprinkler system, wherever you want to buy your stuff from, I don't suggest Home Depot, but if you went to our store or Hisco or Irrigation or somebody, they can tell you, based upon what kind of sprinklers you're going to put, what size your pipe should be, your minimum pipe size. Okay. Most of the time, for a yard like, say, this size, you can get away with using one pipe size because it's small. Okay. If you had a yard that was 5 times the size of this, then I would recommend that you use all the different pipe sizes because.
So the big you gotta provide in the sizes of pipes that the water to the same pressure all the way around.
Basically, yeah.
So it would be like a ½ inch down to small up.
Yeah. Yeah, you could use all 2-inch pipe and it'll work great, but 2-inch pipe can flow 60 gallons per minute. And for this little area, you don't need 60 gallons per minute, you probably need 20. So,
When the water sources at far distance.
okay. Good question.
Far distance and then you bring it towards.
Okay.
Bring it up when we make what's going on.
If you're stealing water from the neighbor and they live far away. Okay. Here's what happens. Whenever water has to go a far distance, the pressure down there is going to be weaker than where it started off because of friction inside of the pipe. So here's a pipe, and water's running through it. By the time it gets out over there, it's always going to be weaker. From here to there, it'll be weaker. But if it went 200 feet more, it'll be even weaker. The rule is pretty simple. So if you can imagine yourself, and you were on an obstacle course, and they had this pipe, and you had to crawl through the pipe to get to the other end. Okay, if it was a short one, you would get through pretty unharmed, right? Even though you're rubbing and squeezing through. We bought already. So if it was short, yeah, you can get through the other end pretty easy. But if it was 500 feet long, by the time you get on the other end, you're going to be pretty bust up because you've been rubbing and squeezing. And water is the same thing. So how do we make it better? We make the pipe real big so I can just walk through, right, without touching anything. So water is the same. Whenever water is rubbing against a surface, it gets weaker and weaker. So if you got to go far, make the pipe bigger.
Bigger, and then go down smaller, for like a bin touring system.
Okay. What happens is you run the big pipe. Okay. Let's say you want to have a hose. Okay. And the hose is this big. Right? You don't need a pipe this big, right? So off of that big pipe, what are you going to do? You're going to have a little tap that's only going to be this small. Okay. The reason why it's this small is because that's all you need. That's all the pipe is. Okay. So reducing the pipe doesn't make it stronger. It actually makes it weaker because remember the water got to push through. It's like me trying to push you through that small hole. You can come out bust up when you come out. So it actually makes it weaker. But because this is all I need, that's all the... So sprinklers are kind of the same way. The sprinklers only, the hole in the sprinkler is only this big. We don't need a pipe that big, right? So, but to get it there so that I can put on my hose, it's better for me to keep the pipe big. That way, as the water is getting to that point, it's as strong as it can be.
Big all the way to the point of exit.
Yeah. Yeah, and only at the point of exit is where you're going to reduce to what your need is. Now, if you need to put, so in the roads, okay, I think this is a good way to explain it. In our roads, our water pipe system is like this big or bigger, right? When it comes up to the fire hydrant, the pipe that's coming up is this big. Why? Because the hoses of our fire hoses are like this. That same line goes to your house, but when it goes to your house, the pipe that goes to your house is only this big. Why? It's still coming out of a line that's that big. The reason why is because that's all the water we need. Why run a pipe this big? Because we're never going to use, the full value of that size pipe. Does that make sense? Okay. Good questions. This is actually design school questions you guys are asking. Any more? Okay, so what is this for? What is it called? Flow control. Okay, so it's used to regulate how much water goes through the valve. Okay, in this system here, it's much smaller than this one, so the valve doesn't need to be open as much on this one as it does on this one. Okay, that's what that flow control is for. Another reason for that is if this sprinkler here broke or there was a break in the pipe and the water was gushing out, I can actually flow control it all the way to the point where no water comes out. Okay? But that's not the function of it. It's not for shutting it on and off. Only in a case like this. Okay? This pressure regulator, up here is the solenoid where the power goes to turn it on. We got two types. AC, alternating current, that's what you get out of the wall. And DC, battery. Okay? Two kinds of controllers, basically. AC controllers and battery controllers. That's why we got different kinds of solenoids. So if you ever see a valve with a solenoid on this, like this, with two different color wires, probably a battery operated controller. Do not hook it up to one of those other kind of controllers because it'll just fry this. Okay? That's just a close-up picture, but you guys can't see it because of the light anyway. Can you get one of those light pictures? Okay. This is a manual valve. This particular one is called an angle valve. So, if you remember, the gate valves normally will have a handle like this. Those valves have a handle like this. Okay? The reason for this kind of handle is it's not a shut off by hand. Usually it's some kind of a tool. Okay? Or tool could be put on it. I gotta be careful with what I say. The tool. So on this one, lots of times they're deep. So you'll see people have a key, has a little U on it, metal, and they put it down and they turn like this and turn the valve off. Okay, so this is a manual angle valve. Inside of this valve, there's a rubber seat that shuts off the water. So right under here, the water goes like this, and then there's a rubber seat. So when you turn that handle, it goes down and it closes like this. This is a good way to turn off water. Because it's metal and rubber, it'll shut it off all the way. Okay. Normally, people will use these just before these. Because lots of times on sprinkler systems, this main line will go this there, and you'll have a couple more of these valves. So they'll use one of those valves so that if they ever needed to work on this, they could shut it off here. They didn't have to shut it off all the way up over here. Okay? So that's what that is. Okay. Have you guys ever heard of the term Schedule 40 pipe? No? How about class pipe? Those of you who have, what is Schedule 40 pipe? What is versus class pipe? Which pipe do you think is better? Yeah, exactly. Okay, so there's Schedule 40 pipe and there's class pipe. Some of our customers will come in and tell us, I'm putting in the sprinkler system, I only want Schedule 40 pipe. So I ask them why. They go, because it's thicker. And they're, generally speaking, they're correct. It is thicker pipe. Now, one of the things about sprinkler pipes, just like the size, if you were putting in an irrigation system or a sprinkler system, you should always choose the material for the situation. Okay. Most of the time, we use a thicker pipe on the main line, and the reason why is because it's always under pressure, so it should be a little bit tougher. Okay, and then the lines where the sprinkler heads are, the only time they're under pressure is when the sprinklers come on and they're running. But they're not really holding pressure because water's always coming out. It is under pressure, but it's not. This one is always under pressure. Okay? So usually we use Schedule 40 on these lines. But some of our customers feel safer using Schedule 40 on this line and on this line. Okay? Because it is normally a thicker pipe. And I use that word normally. I'm going to show you why. Okay, so one thing about class pipe, they come in different ratings. So some people still sell class 160. What 160 means is 160 psi, pounds. That's how much pressure it can handle. Nowadays, most of the pipe that we sell is class 200. You guys remember what I told you how much pressure sprinkler heads need typically? 30 to 60? Yeah, 30 to 60. Is that strong enough? And is that strong enough? It absolutely is. Okay, let's look at this thing here. Schedule 40 pipe. 1 inch. 450 psi. Inch and a quarter, 370. Inch and a half, 330. Is this strong enough pipe for us? 2 inch, 280.
So the bigger the pipe gets, the lower the pressure.
You see that, huh?
Yeah.
You're right. Why is that? Because it's a thickness rating, and I'm not sure how they came up with that Schedule 40 rating, but it's some kind of a, do you know, Darryl? It's some kind of a measure of thickness. Okay, so here's a pipe. It's this thick, but it's this small. It'll hold a lot more pressure if it was this than a pipe that's this thick and this big. Okay, if you needed to keep the pressure, the pipe has to get thicker and thicker as it gets bigger. Okay, so that's why the pressure starts to drop.
So it's the IP.
It's a
IP. That's the
inside diameter.
That's why it's not the thickness.
It's the thickness of the pipe. The outside diameter is the same.
It's like,
Sorry.
oh, no.
Okay, a 1-inch pipe, no matter what radius, it's 160 class 200 or Schedule 40. 1-inch pipe is always the same on the outside. The inside there, as it gets thicker, it's the inside that gets smaller, not the outside getting bigger. Okay, so 1-inch pipe is 1-inch pipe, just the thickness of the pipe. So when it gets thicker, the inside gets smaller, inside diameter. Okay, so let me back up here. Let's just use 1 inch. 1-inch Schedule 40, its pressure rating is 450. 1-inch Class 200, pressure rating is 200. 1-inch Class 160, its pressure rating is 160. So you see, that Schedule 40 pipe is actually thicker than any of these. So is it better? Normally you would say yes. What are we using it for? If it's mainline, yeah. Okay. I would probably choose the thicker one. But if it's a lateral and only running 30 to 60 pounds, 450, which one do you think costs more? That one. Okay. Now, in Kona, everybody uses Schedule 40. You know why? In everything. You know why? Because inside the ground there's choke rocks, lava rock, all kind of rough. Yeah, so that pipe is tougher. So would I use it there? Probably, because of what I'm using it for. Not just sprinklers, because I got a really nasty situation I'm putting it in. But if it was in Lanikai and sand, I'm going to use this one. Because it's cheaper. I'll make more money. Okay? Not diamond head, but if I was installing. I love to sell people this pipe all the time, but I'm going to advise you to use the pipe for what? For the right situation. So here's another one. You take a close look at this. Class 200 pipe. 1 inch is 200. Inch and a quarter is 200. Inch and a half is 200. 10 inches 200. Okay? Look at what happens here. Look at what happens here. Which one is thicker? Okay? Now, when I say most of you, for most cases, this will always be the thicker pipe because very rarely you're going to get up in this area. Okay? See how close it is at the point? Yeah. The people that use this size pipe are waterline guys, golf courses, yeah. Places, really huge projects where they got to push water really far. So a lot of times when you see big systems of parks, they use big main lines. Most of the time they're over here. Okay, there's two reasons for that. Number one, water pressure. The pipe gets thicker when it gets big, over 4 inch. Okay, so it's actually a stronger pipe. And this kind of pipe is always a glued joint. It's super, super hard to glue a pipe this big and do it right or well. The other reason, well, I guess 3 reasons. is the other kind of pipe. They're called gasket pipe. It's rubber inside, and the pipe goes together and it moves. Okay, kind of like a shock absorber. There's movement. Whenever you got large volumes of water going through a pipe, you want the pipe to move a little bit. Yeah, because if the joint isn't really perfectly super solid and doesn't move, it's going to break. These pipes are much more forgiving. Okay, so which pipe is better? It depends on what you're using it for. Okay, and what's your situation. Schedule 40 isn't always the best pipe to use. Okay, and I guess, of course, cost too. Does this make sense?
How does that happen? How does the pressure drop so bad on these ones? How do that?
It's because the pipe gets thinner as it gets bigger.
Why they not making it equal?
That's why they have this. That's why they have the pressure rating.
So they actually
200.
make the glass thicker when it becomes bigger.
The class pipe gets thicker because it's what the pipe is class 200, meaning that it will always be able to maintain 200 psi no matter how big the pipe is or how small it is. If you put these two pipes together, two 1-inch pipes together, you would see a visible difference between the two. Thickness. Yeah.
So the difference between 2-inch and a 3-inch on a 40, so it drops drastically from like 1.5 to 2 inches. The difference is 50 psi. But 2-inch to 3-inch is 50 psi. It goes back up to 40.
Yeah, I don't know.
Is that because it's getting bigger inside?
It might be the difference between the pipe. There is this range here, the pipe as it gets smaller and smaller is not that much. But the difference between 2-inch and 3-inch pipe is big. Yeah, 3-inch and 4-inch, the difference is big. So that's probably why. Don't you agree with that? Yeah, it gets a lot bigger. Okay. I don't want you guys to focus too much on the numbers, but what the point I'm trying to get across is, like before, always use the material. What is it used for? And that's how you're going to choose. Okay. You only need to run one faucet. Are you going to run a pipe this big? Will it work? Yeah, it will, but it's going to cost you a heck of a lot of money just for one little hose bit. Okay. So, or unless you got to go miles and miles because you're stealing water, then okay. Let's see what comes next. This is called a spray head. Normally, anywhere, the books say they'll go from 4 to 17 feet, but effectively, they're probably between 10 and 15. And if you guys were installing it and you came and asked me for advice, I would tell you somewhere between 10 and 15. Everything below that is a little bit weird, and anything higher than 15, no. Okay? So, I'm going to tell you, 10 to 15 feet. This particular one, what I did was I turned the spring around so it stays up all the time because it's hard to pull up. Okay, what happens is the spring is on the other side, and when it's not running, this thing is completely flat. When the water pressure goes behind it, it pushes against the spring and pushes it up. The spring is what pushes it back down. Okay, so I can do that with. So let me demonstrate real quick. I'm getting used to running without the light. No, I'm good. No, you don't want. The picture's not as important as what I'm going to show you guys now, because this is the way the sprinkler head is in an off position. It's spring loaded. Water pressure goes in here, and it pushes it up. When the water pressure isn't there, the spring pulls it back down. I'm going to leave it like this for you guys. Okay, there's a couple components. It's on the slide, but if I pass this around, you guys get a better view. This is called the nozzle. This is called the screen. Screen goes in first, then the nozzle. What these things designate is how far it's going to go and the pattern. Could be like this, or a full circle, or a quarter, or one little stream. So this is a spray head. You guys see this in most people's yards. If you guys want to push it up, the easiest way is to stick your finger over here and kind of get it started. And then you can pull it up, or your pen, or whatever. Okay?
It stays up, water's up.
Something wrong. Yeah, probably something got stuck in here and there's a wedging and open. Okay? Now, they're designed to be buried just at the dirt level. Okay? This is a lawn pop-up. Okay? The reason why they're designed that way is because most of us shouldn't be cutting our grass down to the dirt. If you cut it down to the dirt, you're going to hit the sprinkler. But they're designed to be there, so grass grows on top. You cut it whatever height you're cutting. When the water is there, it pops up above the grass. So you should never see big donut holes around each sprinkler head. Some people still do that. I see it every once in a while. Okay, we don't want to know where these things are until they come on. Okay. And if they're installed properly, you don't have to worry about your lawnmower. You see that still yet once in a while? It's usually the older people, yeah, that not used to stuff like this. So they want to make sure they don't hit it, so they dig one hole, one dirt spot. So, okay, so, because in the olden days, they didn't have springs and nice seals. So if a little piece of grass got in here, it would mess up the sprinkler. But nowadays, they make them real good. Okay? So, that's that. Oh. There is a flow control on sprinkler head. There's a little screw on the top, and that's what you're going to use this thing for. If you win. But the flow on the sprinkler head is really just super minor adjustments. I wouldn't recommend you turn that more than 20%, because then you start to affect how the thing works. They're actually meant to be installed fully open. If it goes too far, maybe choose the next size down, because they have those differences. Then in the parks, we have these things called gear rotors. Yeah? Yeah? So, here's one. This one has a stainless steel shaft. This is a really strong spring. I'm not going to take this one. I did the same thing. I took the spring off, put them underneath so it would stay up. Okay? You're right. So, you know, when you guys are adjusting, because this has happened to me, because these things are on the ground, yeah? And when you turn on, they come up. Yeah, when you get better at putting in sprinklers, you get to know what all these little signs mean, so you know which way the sprinkler is. Because we used to catch all the new guys, because one of the things we used to do is when we turn on the sprinklers, we gotta adjust it up. So we tell the guy, okay, go see the sprinkler head right there. Go stand over there, because when it comes on, you need to make sure and adjust them. So that thing will be right there, and it will go. Because it does come up fast. So you can take a look at this and see which direction the water comes out. You make sure you're not standing in that one spot. You did that, Daryl. Plenty times to people. It's always the new guys too that catch gas. So what those are, you guys remember those heads that go impact heads, okay? These are basically an improved version of that. They're called gear rotors. So I'm going to pass this one around so you can see the actual gears in there. The water goes up, it spins all these gears. That's what makes the head move. Do that.
Yeah, the old one, what's that? The one getting at 10 ladies.
Yeah, it's called the impact sprinkler head. And we don't use them too much anymore. Some people still like them. These are ranges anywhere over 15 feet. Yeah. Yeah, the thing just shoot like that. So in Kapiolani Park, you get this kind. Yeah, they don't do that anymore. Most of the places nowadays use this type. You got them on the freeways too. You might know better than that. $27, $30. Okay. Those heads have different sized nozzles, and that'll how far it goes, how much water it puts out. Yeah, how the thing actually functions. So the screw, not really. It's supposed to be. Huh? You worked with these before. Okay. So there's a little screw that goes in the front here. What it's used for is to hold the nozzle. But its right position is totally unblocked. Because the way the sprinkler head is designed with the right pressure, it'll shoot out like that and it'll drop water all the way along its path. Yeah? Once you put the screw in front of the water flow, it messes that all up. It might look good, but that doesn't necessarily mean the water is even.
Some you might have to.
Some you might have to, that's true. But most of the ones you shouldn't. Darryl, how much one of those? PGP. Not that much.
Depending on the ice, anywhere 25 to $40.
You know why I'm asking Darryl is because although I work for Diamond Head Sprinkler, he buys from me, but I never ring up customers and I don't know any of the prices, so it makes me a real good salesman. Doesn't look like I'm trying to hard sell you or anything. I can only sell features. So, but most of the time people come in and ask me for a price, I have no idea. Sort of. Depends. This is called a bubbler. We used to call them flood bubblers. What they're designed to do is just drop water in one spot. So, where would it work good? Lots of times we'll have a big sidewalk and a little square cut up and one tree going out. Yeah, you put any of those spray heads, they're going to overspray, hit the sidewalk, people can slip, crack their head. So they use those bubblers just to drop water right there. Really super high flow, that's why they're called flood bubblers. They're usually used to flood an area. Okay? So another place you'll see where they use them but you won't see them is a lot of times these tree wells that have grates on, underneath, they got bubblers. Just a close-up picture of the thing. Okay. The picture that I got here is a clock, a controller. Valve 1, 2, 3, 4. Over here, let me get valve 1, 2, oh, there. 1, 2, 3, 4. Okay. How this works is there is a wire called a common wire that comes out of the clock and it goes to every single valve. Okay? And then there is a wire that comes from number 1 and it goes to valve number 1. And there's a wire that's hooked up to number 2 right here and it goes to valve number 2. And then 3 and 4. They broke my stuff. Good spring, huh? Okay, so common wire, all valves, and each valve has a numbered wire that comes from a numbered part over here. Numbered terminal. Okay. So how this whole thing works is in order for valve number 1 to come on, we have to have electricity coming from the common wire and only the wire that goes to 1. That's a complete circuit. So when the clock says valve number 1 comes on, it sends out 24 volts with the 2 wires collectively common and the station 1 wire, the valve comes on. That's how we control only one valve at a time. So each valve is wired up to a certain post. I'll show you closer up. Is that a little clearer? There's valve 1, here's a common wire. It's hooked up to COM. Okay, and this one right here is number 1. It goes down. Okay? Now remember, the solenoid is a coil of wire. So when I send up, what is that? I know what it was. So I got 24 volts coming here. As long as that 24 volts is here, that valve will stay on. Okay. If I cut the wire, one of the wires, any one of the wires, then this will not come on. Okay, it'll stop in its tracks. So what's my solution? Battery out. I could show you how to fix that. Okay. Let me turn on the lights real quick. I had lots of conversations with Department of Transportation with Chris Dacus. And one of the problems, most common problem with irrigation systems as they get older, sometimes even when they're new, is the wiring. And a lot of the problems is with original installation, or when somebody's working on it. A lot of the problems is with waterproof connections. So it's very critical. You could have a really expensive sprinkler system. There's a lot of wires out there. Once something goes wrong with the wire, the whole system starts to go downhill really fast. Some of the reasons is if it doesn't work automatically, we might put in a battery out, but oftentimes people are going to start doing things like feeding it manually, turning the solenoid, doing all kinds of things, and then the whole system starts to go down. So we thought it was really important that we set some kind of a standard for what kind of wire connector we're going to use. So this is it's in your book. This is a new DOT standard that we're going to try to implement, and what it is with this particular connector. This is called a DBRY6, and the RY is because of this wire nut. It's red and yellow, and this particular wire nut is designed to take a whole bunch of different amounts of wire. It used to be before they had a DBR with a red wire nut, and then they had a DBY with a yellow wire. What they've done is they've combined it so you only have to have one. Okay, not two different sizes. Okay? Now, the other part to this whole thing is the 6. So it's a DBRY6. The 6 stands for 600 volts. And that's how this connector was tested. We only use 24 volts. Okay? So here's how it works. Because of the 6, this particular connector is designed and it is listed, UL listed, for direct burial, which means you can bury it in the dirt and forget about it. It is listed for that purpose. Almost every single other wire connector that you guys may be using, although they might say direct burial or waterproof, are not listed for that specific purpose. This one is. Test it.
This one's waterproof.
Waterproof, watertight. The way they test this is they make the connection and they sink it in water and they charge 600 volts. That's why that 6 is there to it, to make sure that there's no leakage. So that's how this thing is been. Can you splice wires, put them underwater with this? Yes. Can you bury it and forget about it? Yes. Have I used this underwater? Yes. Could be good for a boat too. Okay. The secret is in this gel and the way it's constructed. So I'm gonna let you guys do it, see how this thing works. Okay, but let me tell you this. The gel is what's important. There's gel inside here. How this thing is designed is one-time use. So if you make a splice and you pull it out because you made a mistake or you're not sure if you put the right wires together, it's no good. You gotta throw them away, get another one. Okay, one time. We're going to do that later. Okay. So if you guys are out there inspecting like one of your contractors' work and it's a DOT project and they just put it in, it should have these wire connectors. And I would expect them, we'll check the spec to make sure it's actually written in, to put in what was spec'd on the job, because it does make a huge, huge difference. One of the things about the gel that I learned, before all the other wire connectors is in the ground, over time it starts to liquefy and it spills out. Then pretty soon there's no more gel inside. It's not waterproof anymore. Okay, so this one is long lasting and that's what it's for. I should have put that slide somewhere else. Okay, we're back to controllers again, but it's kind of along the same line. Can you catch that for me? Okay, there are 4 things that we need in order for irrigation to happen when you're programming one of the clocks. I call it the critical 4. Current time of day needs to be correct. Nowadays, time and date, because if the year is wrong, the date will be wrong. Okay? So if you wanted to water every Wednesday and you had the wrong date in it, yeah, you know what? It's not going to match, because sometimes the date not going to match that Wednesday is supposed to. So make sure the current date is correct also. So you have to have the current time and date. You have to have days in which it's going to water. You're going to have time when the water is supposed to come on, and also how long it's going to water. If any one of these 4 are missing, you're not going to irrigate. The sprinkler's not going to come on. Okay? We're going to have an example of that. So, here's program A on the clock. Here's my critical 4. Well, I'm assuming that the time is correct. I'm only going to look at 3 at this point. Here's the days it's supposed to water. Monday, Wednesday, Friday. I have, by the way, 7 zones. Okay? Monday, Wednesday, and Friday is going to start at 7. Okay, so I got 3 or 4. The time is correct. I got days water. I got when it's going to start. Now, how long it's going to run. 20 minutes for the front lawn, 10 minutes for the side lawn, 20 for the back lawn, 5 for the annuals, 0 here, 0 here. That means these 3 are not going to run. Why? Because one of the 4 is missing, yeah? The run time. Okay? Make sense? Over here, I have another one. This one's going to water every 3 days. So I have what day of the week it's going to water. It's going to start at 9, so I got that. Okay, let's go down here. 0, 0, 0, 0. It's missing. So guess what? These not going to come on. But these 2 will. Front shrubs and back shrubs going to come on for 15 minutes. See how that works? So, whenever something's missing, it's not going to come on. What if I set this all up, but I forgot to put in a start time? It's not going to run because something's missing. Or I forget what day it's going to water. Okay? We're assuming right here that the time is correct. Okay, you know what I'm going to do? You guys look at these pictures. I'm going to run through them, and then I'm going to step back and show you physically how this actually works. What this picture is showing us is a pipe underground. That yellow thing is a pipe cutter. They're going to cut a section of pipe because something is broken, and they're going to use that device there, right there. It doesn't make any sense now, but it will soon. And what we're seeing here is a sprinkler head. Okay. Can you get the lights for me, please? This is that thing you're looking at. This thing right here. And here's the T. Okay. What this thing does is it's telescopic. Okay. This is the same size as a pipe here. This is the same size as a fitting. So pipe can go inside of a fitting. Okay. There's a male side and a female side. So this will accept the pipe. This one is like the pipe size, goes into a fitting. Okay. What is it for? If I have a pipe here, and it's broken right there, the old style for fixing this pipe is to use something that I don't have. The old style would have been to cut a section out over here, or cut that bad piece out and put a fitting over here. and a fitting over here, and then glue a piece of pipe in here in the middle. But it's impossible to do because it's immovable. So in order to do that, I would have to dig way back over here, dig way back over here, and lift the pipes up and try to get it in, right? A lot of damage. And if the pipe was bigger, the bigger it is, the farther you gotta dig because it doesn't flex as much.
What about the couplings? So the one thing is, if I do one more time.
Yeah, he's talking about compression couplings. Those are good too, but I think this is probably the more used because I'll show you why. This thing is guaranteed as far as getting it in and getting it right. Those compression couplings that you're talking about, although they are a good fix, you really got to be on. You got to make sure the pipe is in, and because there's a little bit of movement, lots of times people do it wrong and they fail. So this is called a quick fix. Used to be called a slip fix. I think slip fix is a brand name. This particular one is made by KBI. One of the things about this one, and I'm not sure about the others because this is the one that I use, is there's an O-ring in here. What that O-ring does is it'll allow this device to seal no matter what position it's in. The old style, what they were telling us is that you needed to have it completely extended in order for it to seal. It's almost impossible to do. So that's why they came up with the O-ring design. So, now, in pipe repair, we do this thing called the CLT. And I really crack up when I go to that test because you see all kinds of people coming out doing all kinds of strange things. I get to see it, but I've also experienced it in the field. Now, I've been in situations where I go out on a trouble call to fix a pipe, and I dig it up and I find one of these. Stay with me now. And the pipe's broken. And I dig it up and I find another one. And on some very rare cases, what do you think happened? When you're repairing a pipe, you should only need one of these and a fitting. Okay? The reason why there's multiple of these is because the guy that was fixing it made a mistake. So you have to use another one. The weird thing is these things go in and out, so it seems like it should be a really easy fix. That's why it's called quick fix, right? So this is what happens. The pipe can only go into the fitting so far. Yeah, this will only go in. And the pipe can only go into here so far. So somebody might go like this and go, okay, can go in that far. That's how much they know. So the guy goes out into the field with his tape measure or his pen, and he's got a cut right here, right? So what he does is he can cut that thing off, and then he'll glue this in over here, right? So here's the T. Now he has this much pipe, only this much pipe because he glued the T in, right? Now he has to figure out what to do with this thing. So he knows this extends. So what does he do? He extends it. He looks over here and he goes, let's see. Pipe can go in that far. So he knows he's got to have at least this plus this, and then it goes in that far, so he makes this measurement. And it goes in that far. So he makes all these measurements, and then he makes a decision. Okay, this is how much pipe I got to cut off. So he cuts off a section of pipe. Now this is what he has. Ready. So he goes like this, and he glues the thing in, and he goes like this and goes. Now what? Now he has to go through the same thing again. He might get it the second time. Okay? Believe me, this happens all the time. Well, the reason why the extension is there is so that you don't have to go like this, right? So, let me show you how it goes. So here's our pipe. The first thing you're going to do is take this and take the fitting because I need to get two female ends, right? I'm going to glue this on here right away, no measuring. glue it on here right away. This is what I have. So, guys, this is what you're going to do. The amount of pipe that you're going to cut out from this thing here is not like this. It's when this is your measure. Okay? Because what you want to do is you want to be able to drop this thing in between. You don't want it to be this far away. You don't want to be too close, because then how you can get it in, right? Just enough so that thing drops in. So, where are you going to cut? Right here, right here. That's all. Okay? No measuring, no tape measures, no pens, nothing. You know why? Because doing it up on the board is one thing, doing it above ground is one thing, but when you're in a hole, and the thing is below ground level, and there's mud and there's water, it's super hard to be exact with all the measures. So use this, okay? So the idea is now this thing can slip right in. You don't have to move any pipe or struggle with everything. This slips in, you glue it in this way. The next thing you do is you pull this out. You will always, always, always make it. If the O-ring wasn't there, then we would fail. But because the O-ring is there, it doesn't have to be all the way extended. It might be this much, but you can hit it. Okay? Make sense?
Excuse me.
Yes.
Why do you cut the teeth?
Because,
So when you start it off with a broken pipe,
oh.
you used to have the sleeve.
Yeah, you can use a coupling, but I just grabbed that from my shop. You can use a coupling and just a hole, but lots of times, you know, it's a sprinkler head is broken. So they got to replace a T or something happened. Usually it's at a joint. Only time where pipe usually breaks in the middle of the pipe is somebody would put a tent stake or something like that. Makafiri? Uh-huh. You'd figure them out. Yeah. It's good, yeah? Yeah. They get really big. I don't recommend the big ones, but the small ones work good. The reason why is the big ones, when you get a lot of water moving and you got lots of moving stuff with O-rings and this and that, the more area, threaded parts and O-rings and stuff, more chance it's going to leak. And lots of times, big pipes, they're not always even. And if there's a lot of pressure on it, it'll leak. Yeah. Yeah. Right. Everything that can turn usually will have a gasket or an O-ring. Okay. You guys okay so far?
How much is that? I don't know.
Asking the price again? Daryl, how much is it? You don't know. They're not very expensive. Probably one of these, probably about $3-4. Huh? Yeah. So these are good things to have. Okay. What time are we supposed to be done? 10 o'clock? Okay, 10 minutes. No questions, okay? Okay. I'm going to run you through a scenario. We're going to get into a little bit of hands-on stuff, but I got to explain some of this first. I'm going to run you through a scenario that is pretty common, and basically what it is I'm a repair guy and I'm getting sent out on a trouble call. Usually when I get sent out on a trouble call, the reason why is probably the plants are dying because the sprinkler is not coming on and there's no water. Okay. Normally, they're not going to tell you what the problem is, because if they knew what the problem is, they would fix it themselves, right? So they're calling you to figure it out. So this is what happens. When I first started doing this, the very first day that I went out as a service repair guy, my boss sent me out with 3 service calls. I came back at about 7 at night and I had 1 done. I knew how sprinklers work. But my problem was there's like a million things that can go wrong, and I didn't ever finished any of my steps in figuring out what actually went wrong. So over the years, I developed a system for myself on how to get through all of this stuff. So the basic things is what we're headed for. So my number one troubleshooting step was to make sure there's water. Okay, so here we go. Every night at this hotel, the security guard is walking around. Every hour he walks down the aisles and the halls. And he's not a landscaper, not a sprinkler guy, so he never notices the landscaping or the sprinklers. But every night, the sprinklers come on. He don't notice. So he walks down, 12 o'clock. 1 o'clock, he walks down this aisle. The sprinklers are running. It was running at 12, running at 1. He doesn't notice because it's not his gig, right? 3 o'clock, he walks down again. Still running. 6 o'clock, he walks down and now he notices because when he stepped, he got wet. Right? So he looks and he goes, I never noticed that thing running before. Yeah, so now he's thinking, oh, I got to do something because water's running across the sidewalk. So what does he do? Huh? No, you don't call me yet because it's only 6 o'clock. Still yet dark.
He knows a little.
He knows nothing. So what does he do? You're right. Anything with a handle, he's going to turn it. Right? He find one of these, he find one of these, he find one of these. Anything that has a handle, he's going to turn it. So he turns off 6 things. Yeah? The 6th one, the water stops. You think he's going to go back and turn off the 5 that he turned on that didn't work? Hell no, because now it's 7 o'clock. The surf is up in the country. He's forgot about the night, signed his log real fast, throw him back, and he's out of there. 2 weeks later, all the plants are dead. And nobody knows what happened because he didn't write in his log that he got wet and the surf was up. And he's out of there, right? So they call me. What am I going to do? The first thing I'm going to look for is if there's water or not. So where am I going to go? If I can get it out of the owner, the hotel guy, or the homeowner, I'm going to start looking. Where's your master shut-off valve? One other place I can look is the backflow preventer, because when the backflow preventer is handled, remember everything that has a handle, he's going to turn, whether it's related or not, because he doesn't know. He might have even been lucky to find the control valve. So what does he do? There's this green box on the ground. He opens it up. There's water, and he goes, oh, what the hell is that? So he sticks his hand and goes, oh, found one handle. Right? So he starts to turn it. And he looks and, oh, he's getting wet, right? So he's trying to hurry up. And the water starts to get a little bit less. He's like, all right. So he starts turning it. But he doesn't get it off all the way. So what does he do? He sticks his feet inside and goes, oh. Okay. And finally the water shuts off. It's like, cool, close the cover, and he leaves. When the water dries up, there's no sign that anything ever happened. Right? So I get the call. So I'm walking around and looking. If it was this area, I might be lucky enough to find that box. And there's that valve in there. And I go in there and I go like this. And I go, oh. I turn it. This was off. And big deal. I got it on. It was off, but okay, so what am I going to do next? Remember I said there's a couple ways to operate this valve? One of them was the bleed nut, which is now missing. If you turn this, the water comes on, water comes out, and the sprinklers come on, right? I turn it on and the sprinklers come on, and I shut it off. I go, well, that was probably what it was. The water was running, but why was this thing shut off? Yeah, I don't know yet, right? So let me just throw one thing in here real quick. If you have one of those valves that on the top says turn a quarter turn and the valve will come on, do it that way. Don't do it this way. In this case, I only have one choice. But if you can turn this, that's the one you want to go for. Okay, so just keep that in your mind. We'll go over why later. So what am I doing right now? I'm verifying that there's water, because if the water is shut off, no matter what, the sprinkler's not going to come on. So I went to the master shut-off valve to make sure that's on. The backflow preventer is a good place because you know why, those handles are above ground. It's easy to turn off. And then remote control valve. I did a manual bleed. Okay? The next thing I'm going to do is I'm going to go to the controller. So here's the controller. I open it up. What am I looking for? I'm going to check the display. Why? Because I want to make sure there's power. If there's a blank screen, there's a good chance there's no power. Could be just unplugged, right? So I'm going to look. Is there power at the clock? And then I'm going to start looking for critical for. Is the time of year correct? Date and time? Is there a start time? Days it's going to water and how long? If any one of those are missing, it's not going to water, right? Okay? Make sense? Okay, here's something interesting, if this was the clock, about it. You ever watch CSI? Somebody gets bumped off. They say it's this room. What do? They tape the door, right? They put all that yellow stuff. Nobody can go inside. Why? Because if somebody came inside, it might mess up the evidence, right? So you need to troubleshoot. You need to kind of keep those kind of things in mind. You open the clock, take a look at it. If you see something funny, don't just start going, okay, I'll fix them all up, punch off them buttons, because a lot of times what the clock says is what the problem is. It might say fault number 1, which means there's a problem on number 1. If you went and changed everything and never noticed the fault 1, guess what? You just missed something. Now you got a lot of stuff to go through to figure out what went wrong. So treat the clock like a crime scene. If something looks funny, look at it first before you start messing with it. Okay? So, manual start. If this is station 1, I'm going to try and turn on station 1 to see if it comes on or not. And that's all I'm going to do at that point. Okay? Good so far?
Yep.
No, it doesn't come on. Now what? It could be an electrical problem. Here's a couple things I know. Number 1, there's water, right? Because I went to the valve, I turned it on, it comes on now. Okay? Number 2, the clock, all the critical for is there, there's power to the clock, it's working, but it still doesn't come on. Okay? So, my third thing is electrical. It's probably or could be an electrical problem. So, place our hands on. These are not prizes. Okay. I hope I have enough. These are called multimeters. What they're used for is for testing the electrical circuits. No, it's not a prize, and it's not a gift. You might have to share. I got some more. Now, everybody needs one like this. Actually, we're going to have to double up, because I need one. You don't need, oh yeah, you don't need that. Okay. Can we spread some down here? You guys gonna share? Can I get one more backward? Okay, don't do anything yet. I don't want anybody to get hurt. Okay, well, the key to this is not getting hurt, and you won't if you do what I tell you. Okay, I'm going to go this way so you guys are looking at the same thing I am. The dial up here should be all the way to the right, next to that thing. It kind of looks like a horseshoe. That position there is called ohms. What we're measuring is ohms. Ohms is a measure of resistance. That's what we're going to be working with. I'll explain it a little bit more as we go. Then you have a round dial. Okay? The round dial needs to be turned all the way up to where you see this thing looks like a volume control, or maybe a signal for, yeah, okay? What are you doing down there? Okay, the next thing I want you to do is take the red and the black leads and touch it together like this. And you should hear a noise. Okay? And put your two fingers and hold it together. And I want you to look at the display. What do you guys see? Anybody see anything different? All 0 zeros? Okay, stop. Stop. Okay, well, I'm gonna bust this out here. What you just saw is a short circuit. Anybody know anything about short circuits? Are they good? Are they bad? Don't know? He's a short circuit? Oh. It's a good thing then, right? See, it's a good thing. What do you know about short circuits? Typically, what did you say? Trip. Typically, it's a bad thing. If you have a short circuit in your house, electrical, hopefully, it will trip the circuit. And the power will go off. If you have a short circuit and the circuit does not trip, guess what's going to happen? The wires are going to burn. Okay, so short circuits are not typically not a good thing. What it does in irrigation is it'll trip the clock. Okay, so there's no fire, the wires don't burn. We're only working with 24 volts, but bad things can still happen. So what you guys just saw is a short circuit. I do want to say another thing though. A short circuit is a complete circuit. This is not a complete circuit. This is an open circuit. This is a complete circuit. So although it's a bad thing, it is a complete circuit. What this means is that the wire is good. If I had a cutter right now and I cut this, the noise would stop like that. Okay, it's an open circuit or an incomplete circuit. So a short circuit is a bad thing in that it's going to trip our clock. But if we have one, at least I know one thing, is that the wire is good because it's complete. Does that make sense? Okay. So our system have solenoids. So as you get these, what I want you to do is uncoil the wire and take your tester and test the two wires. Okay? You should get a tone and you should get a number. So tell me what kind of number you guys are getting. How much? 23. Okay. You guys got solenoids? Anybody need a solenoid? Okay. Same setting. Okay. Okay, you can stop now. Yeah, that doesn't bother me that much. Okay. Inside of the solenoid, remember? Told you there's a wire. Okay? Now, the longer the wire, what do you think happens? Electricity goes through, what happens? It's weaker because of friction, kind of like water running through a pipe, electricity going across a wire. The longer the wire, the higher the number on your thing is going to be. So that's why when you go like this, you get 0. Now you're putting it on this. What are you getting? 23 ohms. What you're measuring is resistance or friction. Okay? So you got 23 ohms or 24 ohms. What's inside of here is this little tiny, tiny wires. wound up inside of here, yeah? Super, super long. If we were able to cut this open and bust it open, you'd get like tons of wire. And it's a really small wire. So that's why you got a number now. Okay, now, for our solenoids, for our purposes, anything below 10, above 10, and no, above 20 and below 60 is a good solenoid. Okay, anything below is a short circuit. Anything above 60 is an open circuit, a broken wire. Okay, so you can actually test your solenoids to see if they're good enough. Most of the solenoids in this industry stay somewhere between the 20s to the 40s. Yes. Okay. So if you're getting 23, this is like a brand new solenoid. You need probably 24, maybe 25.
26.
It's 26. It's not volts, it's ohms. You're measuring like the friction loss inside of the solenoid. Okay, so you did that, right? You put the, never mind. Where did I put it down? Oh. So you did this. You get 23, I get 23, or 24 to 26. Is this a complete circuit?
Yes.
Yes. The solenoid is just an extension of these two things, right? Now, what do you think would happen if I all of a sudden came and cut that wire? I would have an incomplete circuit, it would be broken, yeah? So I would get a weird number like some of the meters, like this one reads nothing, like a 1. Some of them jump all over infinity. It's a broken wire. Okay, so now with all of this knowledge, what are you going to do? Buy me what? No? Solenoid's good. Okay, and in your controller, you have a common, then you have a station 1, a station 2, station 3, and station 4. What I'm going to do, I'm going to come up to that controller, I'm going to open the box, but make sure the controller is off. You can even unplug it, that's probably the safest way. And I'm going to put this to where I had it, and I'm going to go to the common, and I'm going to station 1. What am I looking for? I'm looking for a complete circuit. I'm going to get a tone, hopefully. Yeah? And then I'm going to get a number. What if I read 23? That means that at the end of that thing is what? At the end of these two wires, there's a solenoid. Okay? So, okay, I just did station 1. It's good. I go to station 2, and I read 0. What does that mean? I read 0. That means I got a short circuit. Okay, so let me draw this out. Over here, I have my solenoid. I'm going to do it this way. This is number 1. Number 1 wire goes to number 1. Here's number 2. Here's number 3. Number 3 wire goes here. Number 2 wire goes here. This is my common wire. It goes to 1, then it goes to 2, then it goes to 3. So, when I go like this, I'm testing these wires going to 1. When I go like this, I'm testing these wires going to 2. And number 3, right? To 3. So I tested number 1 and I got 23. I tested number 2 and I got a tone and a 0, 0, 0. What does that mean? I have a short circuit. How can that happen? It could be the solenoid, right? It could be the solenoid. Inside the solenoid, there's this coil of wire. This is what happens. Every day the sprinkler comes on, goes on and off. What happens with electricity? It makes the wire warm. That wire has lacquer on it, so it doesn't touch. It goes cold and warm, cold and warm. That lacquer starts to wear off. Somewhere along the line, the wires inside touch. What happens? Short circuit. Okay. So if I go here and I test and I get a short circuit, there's a good chance that it's the solenoid. So what is my next step? You know what I'm going to do? Is, I didn't draw this too good. These little round black circles are wire connectors. Waterproof wire connectors, right? Okay. So see that? So I'm reading a short circuit on station 2. So what I'm going to do is I'm going to come over here and I'm going to remove that splice. And then I'm going to go and test the solenoid. What should I get? What do I want? 23. What if I get 0, 0, 0? That means something happened here. So what do? Change the solenoid. I put it back together. What kind of wire connector do I use? DBRY6. Then I'm going to run back to the controller and go like this. And go 23. I solved my problem. Now station 2 will come on. By the way, when I went to the clock, and I opened the door, it said fault 2. Kind of give me a clue, huh? I got a problem on station 2. I'm going to be looking for something on station 2 because I know already something's up. That's probably what that fault meant. Sometimes it'll say fuse 2. Okay. Okay. If I go here and I go and I get 0, what does that mean? That means I have a complete circuit. So what that means is I know my wire is good, right? So I don't have to think about this now. I got a good wire, but I have a short. So what I'm looking for is the short. Okay? So it's important for you to understand incomplete and complete. That way you won't make the mistake, or it'll speed up your troubleshooting process. Huh?
Is the AC always 24?
No. Oh, you mean the solenoids?
Yeah.
Let's find out.
I'm always gonna have, every time I use the AC, it's always gonna be 24. Like 0.
No, somewhere in there. The DC solenoids are reading 004. Probably means a shorter coil, not as much. Okay.
So I'm gonna know that, or this is gonna tell me blank.
It depends on what brand you got, but there's a range where we should be safe. Okay, above 20.
And that's supposed to know that.
Yeah, you better memorize that. Yeah, if you keep doing this, you start to know these numbers. Like, there was a point where I was doing troubleshooting, and I was doing it so much that I would go to the clock, and because of the number, I knew what kind of valve they had. Because different brands have different values. Okay, so anyway, I read a short circuit, I fixed that. Okay, on station 3, I came in and I went like this and I never get nothing. What does that mean? It means I got a broken wire. So now I gotta find that broken wire. Okay. Remember, one of the reasons why we spec that connector is because a lot of times that's where the problems are. And I suspect a lot of times when I go troubleshooting that it's a splice that went bad. So if I find a broken line or a broken wire, my instinct is to go to the splices first. So I'm going to go to that splice on station 3 to make sure. Okay, another place that it can go bad is here. Because sometimes people, you know how they turn the solenoid, turn it on and off? Sometimes they're like, and these wires are like, and it breaks inside there, but you cannot tell because the red covering is still there. All kinds of weird things can happen in sprinkler systems. So I'm just telling you a couple real obvious, easy fix things to look for. So this is what I'm going to do. Again, I'm going to come down here to station 3 to test over here by the solenoid. But here's something different that I do on a broken wire than I do on a short circuit. On the broken wire, I take the common wire and station 3, these are the two that I'm dealing with, and I connect them together with the wire nut before I leave the clock. I take them off the post and I put them together. Okay? Then I come down here and I take off the splice. The first thing I'm going to do is I'm going to test the solenoid. Okay, I get a tone and I read 23. What does that mean? The solenoid is good. What if I don't get a tone? Because if I don't get a tone, that means something in here. Because I should get a tone and I should read 23. If I get nothing, that means there's a broken wire inside of the solenoid. Okay, here's something else that I do though before I even change that solenoid. I'm going to go to the wire, number 3 wire that goes back to the clock, and the common wire that goes back to the clock, and I'm going to test that. What do you think I'm going to read or should read? What am I looking for? I'm hoping that I get a complete circuit. I'm hoping that I read a short circuit, because that's what I did, yeah? Yeah? And if I read a short circuit, what does that mean? That the wire is good. Okay, so if I went like this and I read the solenoid 23 and I read over here short circuit, what do you think that means? Huh? The wire is good, that's a complete circuit. So, yeah. Something was wrong with the splice. Does that make sense? Good? See, so this, the reason why I did this was to save myself some steps. So I didn't have to, what I would do is go put the splice and run all the way back to the clock and test them back to say again. I don't have to do that. I'm going to go back to the clock eventually anyway, but why go back and forth 3 times? Yeah, just do them once. You hear? I find it, I fix it, like, I know the wires are good, just hook them back up. They're good to go. Make sense?
Timer always gotta be off before you.
Yes. Okay, this is how this works. There's a little battery inside here, so I'm going to ask you guys all, please, when we leave today, to turn it off. Because there's a little battery in here, and it's sending out a small little current to this. And that's how come we get the tone and we get the numbers, because I'm completing the circuits. Okay? So, if you have electricity coming out of those things you're testing, this is going to happen. Yeah. You can blow the fuse in this, and you're dead. Okay, let's talk a little bit about these though. If you guys want to do this, don't just go buy one, okay? I actually think that this is a junk one, but they're really inexpensive. I sell these, and I think they're, I don't know, they might be 15 bucks or something. The reason why I don't like this is because there's lots of places you can put this, and like a million places you can put this. Okay, the ones that I like say auto range. So there's like 3 positions you put this thing on, and then you're testing. But this one you got to go, what is 20VK with the upside down horseshoe mean? So you got to know all that stuff, and most of that stuff you're not going to use. So if you have an auto range one, then there's only like 3 positions you got to put it. Okay, the tone is always good. Okay, because you can get through things pretty quickly if you have that tone. Because there'll be situations where I'm talking to the owner and I'm just going like this, talking to me, trying to pay attention, and I'm listening for all these things. I already know, I get tone in every single one. I know there's no broken wires, right? Right? Complete circuit. I never even look at any numbers. So I just finished doing this whole thing in about less than a minute, yeah? 30 seconds. I tested all the stations. Okay, no broken wires. Then, after they walk away, then I start looking at the numbers to see if I got any short circuits or whatever. Okay? So that's why the tone is good. Questions? So what we've done so far is we went out to our system, we found out that the security guard turned off 6 things, We turned them all on, found out that he did find the valve. So we got the water on. That's a good thing. We went to the clock. Controller program is all correct. We had some problems we weren't expecting, like there was a short circuit on station 1 and a broken wire on station 3, but we still didn't get this section to come on. We went to 3 things. Those 3 things you're not going to think about. If you do this well, you're never going to have to think about those 3 things again. You only got one more thing that can go wrong, and it's the valve. It's this valve. Okay? You guys with me? So, we're almost done. And if you don't ask any questions, we'll be done in 5 minutes. Can you hit the light for me, please? Okay. If you want to, after we're done, I have that valve right here, cut in half. It's a pretty typical valve, and that's why I use this, even though this is an old style valve, it's still current as far as how it works. Okay? Only difference is when they cut this one in half, they cut it this way. That one is this way. Okay? So, but all the parts and everything are exactly the same. So, I always lose stuff. You know when else I lose stuff? Is when I'm building stuff. Like I always put my pencil down, cutting wood. My tape measure, my pencil. Okay, so this line right here that I'm with my red highlighter is called where the diaphragm is. Okay, here's the diaphragm. Okay, the diaphragm separates 2 chambers. This chamber and that chamber. Everything that you see is blue is water. Okay? So what happens on this valve? It's in a closed position. This is the main line coming in this way. This is where the laterals are. This is where the sprinklers are. So it's in an off position, seeing no water. Okay. Up here is a solenoid. Over here is a bleed nut. If I open this, water will come out and the sprinklers will come on. Okay, so how does the water get up to here? In the middle of the valve, there's a little pin, a little chamber. Water goes up through here and it fills up this top chamber and it fills up all inside here. Okay. The reason why this valve stays on is 2 reasons. Number 1, there's a spring, which helps. But the main reason is because of this chamber separated. From here to here, there's an area like this wide. And from here to here, there's an area this wide. The bigger area is going to win, keeping the valve shut off. Okay? So that large area. So the only way for this valve to come on is to somehow make this area smaller than the force coming in this way. See, now it's bigger, so it's winning. Okay? So how does that happen? 2 ways. Number 1, we turn on the clock, electricity comes through here, and it lifts this plunger. Remember that? Okay? When you lift that plunger, water is able to escape through here. And when it escapes through here, the water from here goes away. And then the valve comes on. The other way is for me to open this bleed nut here, water comes out into the valve box. Same thing, water is escaping here and it goes away. Okay? Make sense? Okay, check this out. This is kind of cool. Very. Oh, where's my sound? It's supposed to be sound. Wait. That's very important, you know, you get the full effect. Now you see it. Okay, one more time. Okay, you guys see that? Anything kind of cool, huh? Okay, so the water's running. So this security guard will be famous by the end of this class. So he's walking around and the water's running, getting his feet wet. What's happening is a little rock came through here. And it was flying through, it got stuck over here. What happens when it gets stuck here? The valve cannot shut off because the rock is in the way. So he's walking up and down, the water's running. Then he finds a handle, starts to turn it. Feels a little resistance, so what does he do? He sticks his foot in there and he starts cranking down on that thing. So he forces it down. And you can do that with a brass valve. So it's a little piece of cinder. So it crushed, one piece went that way, clogged up a sprinkler head, and the other one fell over here. He got the thing shut off. So when you came, remember we came and we found the box and we went, hey, it was off, and we turned it on and what? No water came out. We're thinking, wonder why that thing was turned off. Because maybe that happened. Okay? Are you guys with me? No questions? I lied. We're not going to be done in 5 minutes. Okay. Any questions now? You know that guy that put in a sprinkler system? That guy Martin, like 20 years ago, he never flushed out the line good enough. So the rocks are rumbling around.
Everything's working, but it's not coming back on.
Yeah. Oh, how come it's not coming on? Because remember the guy when shut him off? Yeah, that's why it wasn't coming on. So you came and you turned it on, and you're thinking, how come the valve was shut off? It's because the rock went through, and he forced it off. But now when you go, the rock's not there. Now that when you turn it on, it goes on, it works fine. You're thinking, what happened? But here's something that does happen when the guy does that. This rubber piece right here got dented. Yeah? So now when the valve shuts off, it shuts off, but a little bit water leaks by. 24/7, a little bit water leaks by. And then all of a sudden, that sprinkler head on the corner of the walk, it's wet and get moss. And it starts to run across the sidewalk. It becomes a slipping hazard. You're wondering, that was never there before. What happened 6 months ago? We had that security guard did that thing. He damaged the valve. Now we got a weeping system, yeah, with moss and mosquitoes. Okay, you guys with me? Okay, what else can go wrong here? What if there was a tear in that diaphragm, in this rubber? Right here. Right here.
Stay on.
Why would it stay on? Because the water leaking out? You're right.
Bringing the plunger up back.
No, if there's a tear here, the water from here is going to escape. Yeah? Same thing as when the plunger goes up, yeah. So if there's a tear here, the water's going to escape and the valve's going to open. Okay, so this is what happens. These guys come into my shop in the morning. They go, can I buy a diaphragm? You guys got this? And I go, sure. How many do you want? Oh, just one. I'm having a problem with the valve. Oh, okay. So he goes away. His problem is the valve is not coming on. You think it's a diaphragm problem? If it's a diaphragm problem, the valve would be open. If the valve isn't coming on, that means the diaphragm is doing its job. It's separating those two areas, right? And this happens a lot. So he comes in, he buys a diaphragm. Then a couple hours later he comes and he buys this. And a couple hours later he goes, you guys sell the top? Sure we do. But what's going on? Yeah, so it's important that you know, that's why we're doing this. Well, you know how these things work. Now, what if a piece of sand came up here and clogged over here, or clogged over here? What would happen? It's not going to come on, because in order for this valve to work, water needs to be able to flow freely through these areas. If either one of them gets clogged, the water from here is not going to escape when the valve comes on. So let's think about this now. Remember when I told you the very first step when you're verifying water source, you went and you found the valve and you turned this handle on. And I told you now what you need to do is to turn the valve on to see if it works or not. And there's two ways to do that. One of them is to turn this bleeder, right? Which is right here. Water goes out, the valve comes on. Close it up, water fills back up, the valve goes off. But I also told you, if you had a choice, if it was one of those valves that has a bleed nut here, not bleed nut, a solenoid, you turn a quarter, I said what? Do it that way. Why? That's true too. Exactly, but that's not what I'm after. Okay, so if I bled it here and the valve went on and off, you know what I'm going to assume? The valve is good. It works. I go to the clock and it still don't work. I check all my electricity, it still don't work. I mean, the electric part is fine. Yeah, I bleed it and it goes on and off, it still doesn't work. The reason why I said to turn the solenoid, because what it does on these new valves is when you turn it, what it does is it lifts the plunger, and when you turn it, just a quarter turn though, okay, not quarter turn, it lifts the plunger up, you know what happens? The water goes like this. So what does that tell me? That it works, that this is clear. What if I turn it and the water doesn't come on? That means one of these is clogged. Okay? So I could go through all the steps and miss one thing right here. Everything tests out right except I didn't check this. So that's why if you have the opportunity to go here, go there first, because it'll eliminate a lot of stuff really quick. You already know just by doing that that the valve works. It'll work electricity if the electricity is there. It'll work manually. So everything, all the ports are clear. Okay? Does that work for you? Okay. Anything else? Any questions? Is it really 10:30 or?
Yeah.
Oh, no, almost 11?
10:30.
10 to 11? Okay. You guys ready for the test then?
We have about 10 minutes until lunch comes, so.
10 minutes? Perfect. Okay. Thank you for not asking any questions. Yeah. Okay, let's hit these lights and let me tell you how this is going to work. Remember I told you there's this prize. There's a CSI flashlight for looking inside that little port. There's a weapon, and there's a screwdriver, and a little pouch for your Batman adult. So, the first person with all the answers correct is going to win this. So it's a speed test. You can cheat, but if the guy next to you has the wrong answer, so it's totally up to you. I don't really care. Okay? This is supposed to be fun anyway. So what happens is, we're going to pass out the test. Everybody face down, no cheating, and we're going to start. The first guy that finishes the test, you got to get our attention. Me and Jay are going to be looking. And we're going to take your paper and we're going to write your name on the board. So you're going to say Daryl was the first one. Okay, put Daryl's name up there. Okay, and we're going to wait. Next guy, 2. Then we get about 6 people. And after everybody's satisfied, some people are not going to want to do this because we're going to expose your test. So the first guy up, Daryl. We start going through the questions. Daryl missed question number 4. Boom, automatically, you're out. So the next guy is in line, right? So the first guy. Now, when you send up your paper, because you guys are cheaters, you're probably going to talk to your friend next door, next to you, and he can go, you put what? You can take your paper back, okay? But if you take your paper back, when you raise your hand and say you finished, you're going to end up wherever you end up, okay? Now, have people, I've done this a lot of times, have people taken their paper back and put it back up and still won? Yeah. Because of the cheaters and wrong answers. Okay. Does that work? So where's the test?